Picture this. You're standing on a cliff at night, the cool breeze brushing your skin, stars glittering like a billion fireflies pinned to the velvet sky. You gaze up, feeling small, insignificant, yet oddly connected to the vastness above. Now, what if that vastness, the entire universe, isn't just a cold, mechanical sprawl of gas and gravity? What if it's alive? Not just teeming with life, but a single colossal organism, with galaxies as its organs, stars as its cells, and you, yes, you, as a tiny but essential part of its grand existence. Welcome to the Great Living Hypothesis, a mind-bending idea that challenges everything you thought you knew about the cosmos. You might be chuckling already, thinking, a living universe? Come on, that's something you'd hear in a sci-fi flick or a late-night Reddit thread. And sure, it sounds wild, like something dreamt up after too many cups of coffee. But stick with me. This isn't just a quirky thought experiment. It's a hypothesis rooted in patterns, science, and a dash of cosmic wonder that's been whispered about by thinkers for centuries. Today, you're diving into the first step of this cosmic journey, exploring why this idea even exists and what it could mean for everything you know. Let's start with the basics. When you think of life, what comes to mind? Maybe it's a bustling coral reef, fish darting through vibrant colors, or a forest humming with birds and rustling leaves. Life, as you know it, grows, reproduces, adapts. It's your dog chasing its tail or the bacteria multiplying in your yogurt. But could those same principles stretch to something as vast as the universe? You're probably picturing the universe as a giant soup of stars, black holes, and cosmic dust, driven by physics, not biology. Yet, there's a peculiar rhythm to it all. Galaxies swirl in hypnotic spirals, stars pulse with energy, and even black holes seem to feed on matter. It's almost as if the universe is breathing, moving, existing in a way that feels eerily alive. Now, let's take a step back to a historical tidbit. Over 2,000 years ago, the Greek philosopher Anaximander speculated that the cosmos was a kind of living entity, an infinite whole with a purpose. He didn't have telescopes or equations, but he sensed something profound. The universe might be more than a random scattering of stuff. Fast forward to today, and scientists are still wrestling with big questions about what the universe is and why it behaves the way it does. The Great Living Hypothesis picks up where Anaximander left off, asking, what if the universe isn't just a stage for life, but a life form itself? Here's where it gets weird, and I promise, this is the quirky detail you didn't see coming. Did you know that the structure of the universe, with its web of galaxies connected by filaments of gas, looks strikingly similar to the neural networks in your brain? Yep. Astronomers and neuroscientists have noticed that the cosmic web, those sprawling threads of galaxies stretching across billions of light years, mimics the way neurons connect in your head. It's not just a cool coincidence. It's a hint that the universe might organize itself in ways that echo life. Imagine zooming out from your thoughts to the cosmic web, seeing the same intricate patterns. It's enough to make you wonder if the universe is thinking too. But let's not get too carried away just yet. You're probably wondering, how could something as massive as the universe be considered alive? To answer that, you need to rethink what life means. On Earth, life is defined by things like metabolism, reproduction, and response to stimuli. But what if those rules are just a tiny subset of what life can be? Imagine you're an ant crawling on a whale. To you, the whale is so enormous, so alien, that you might not even recognize it as alive. Now scale that up to the universe. Could its expansion, its formation of stars, its recycling of matter through black holes, be its version of breathing, growing, or even dreaming. This brings us to a point of academic debate. Can we even define life on a cosmic scale? Biologists love their checklists: growth, reproduction, homeostasis. But those are Earth-centric. Some scientists argue we need a broader definition, one that includes systems that maintain complexity and adapt, even if they don't look like a puppy or a tree. Others say that calling the universe alive stretches the term so far it loses meaning. It's a bit like arguing whether a virus is alive. It depends on where you draw the line. What do you think? Could a universe that births stars and recycles galaxies fit a looser, grander definition of life? Let's paint a picture to make this real. Imagine you're floating in space, weightless, surrounded by the soft glow of distant galaxies. You feel the hum of cosmic background radiation, a faint echo of the universe's birth. Stars flare to life in fiery bursts, while others collapse into the silent pull of black holes. It's chaotic, yet there's an order to it. A rhythm that feels purposeful. The universe isn't just sitting there, it's doing something, evolving in ways that feel almost intentional. You can't help but wonder, is this the heartbeat of something alive? Now, here's a modern twist. Think about the tech you use every day: your phone, your smartwatch, maybe even an AI like me. These systems process information, adapt, and respond. But you wouldn't call them alive, or would you? In 2025, we're building machines that blur the line between mechanism and life. If we can't quite pin down what makes something alive here on Earth, maybe it's not so crazy to wonder if the universe itself is a kind of cosmic machine with a pulse. After all, it's been running for 13.8 billion years without a single software update. Talk about a reliable system. Let's toss in a quick joke to lighten the mood. If the universe is alive, it's probably wondering why we keep sending it selfies from Mars rovers. Another dusty rock pic? Come on, humans! But seriously, the great living hypothesis isn't about proving the universe is alive. It's about asking what alive even means when you zoom out far enough. It's about feeling that shiver of awe when you realize you're part of something incomprehensibly vast, yet strangely familiar. So, where does this leave you? You're standing at the edge of a cosmic mystery, peering into a universe that might be more than a collection of physics equations. It might be a living, breathing entity, and you're a part of it. Maybe a neuron, maybe a spark, maybe something we don't yet have a name for. Before we dive deeper into what makes life life in the next part, let's pause for a moment. What do you think? Could the universe be alive, pulsing with purpose? Or is it just a beautiful, lifeless machine? Drop your thoughts in the comments below, and let's unravel this cosmic puzzle together. Hit that like button if you're as mind-blown as I am. And don't forget to subscribe for the next part of this wild ride. The universe is calling. Let's find out if it's got a heartbeat. You're walking through a lush forest, the air thick with the scent of pine and damp earth, leaves crunching underfoot. Birds chirp, insects hum, and somewhere nearby, a stream gurgles over smooth stones. This is life as you know it, vibrant, messy, and unmistakably alive. But now, tilt your head back and look up through the canopy to the stars beyond. Could that same spark of life, that same restless energy, apply to the entire universe? To even ask if the cosmos is a giant living organism, you first need to pin down what life means. Buckle up, because you're about to dive into the rules of life as we know them, and test whether they could stretch across the vastness of space. Let's start with the basics. When you think of life, you probably picture things that grow, eat, move, or reproduce. Your cat batting at a toy, a tree stretching towards sunlight, or even the mold creeping across that forgotten sandwich in your fridge. Scientists have a checklist for life, and it's not just a vibe. It's a set of criteria. Life, they say, involves metabolism, using energy to stay organized. Growth, reproduction, response to stimuli, and adaptation over time. These are the hallmarks of everything from bacteria to blue whales. But here's the question buzzing in your mind. Could these rules, cooked up on our tiny blue planet, apply to something as enormous as the universe? Imagine you're a scientist in a lab, peering through a microscope at a single cell. It's a tiny world, pulsing with activity, chemicals flowing, membranes vibrating, DNA whispering instructions. Now zoom out, way out, until you're floating above the Milky Way. Galaxies spin like pinwheels, stars flare into existence, and black holes gulp down matter like cosmic vacuum cleaners. It's a different scale, sure, but there's a rhythm, a kind of organized chaos that feels oddly familiar. Could the universe be following the same rules as that cell, just on a scale so massive you can barely wrap your head around it? Let's toss in a historical anchor to ground this. Back in the 17th century, Antony van Leeuwenhoek, a Dutch cloth merchant with a knack for lenses, became the first person to glimpse microorganisms under a microscope. His discovery of animalcules in pond water blew open the idea of what life could be. Tiny, invisible worlds teeming with activity. It was a reminder that life doesn't always look like what you expect. If Van Leeuwenhoek could find life in a drop of water, maybe we're missing the signs of a living universe because we're too close to see the big picture. Now, here's the quirky detail that'll make you raise an eyebrow. Did you know that some fungi, like the Armillaria ostoyi in Oregon, form massive underground networks called mycelium that can stretch for miles? One colony is so big, it's considered the largest single organism on Earth, covering over 2,000 acres. It's like a hidden city, quietly coordinating resources across vast distances. Sound familiar? The universe's cosmic web, those filaments of gas and galaxies stretching billions of light years, operates on a similar principle, connecting distant regions in a network of matter and energy. It's not exactly a mushroom, but the parallel is uncanny. Like the universe is knitting itself together in a way that feels alive. But let's dig into the meat of this. To call the universe alive, you need to stretch the definition of life beyond Earth's playbook. Metabolism, for example. Life on Earth needs energy to function, whether it's a plant soaking up sunlight or you scarfing down a burger. In the universe, energy flows everywhere. Stars fuse hydrogen into helium, releasing torrents of light and heat. Supernovas scatter heavy elements across space. Even black holes radiate energy in weird quantum ways. Could this cosmic churn be a kind of metabolism, fueling a universe-sized organism? It's not like the universe is chugging protein shakes, but the way it processes energy feels like it's doing something purposeful. Then there's reproduction. You're probably thinking, wait, the universe doesn't have baby universes, or does it? Well, hold that thought. Some cosmologists toy with ideas like cosmic natural selection, where universes might spawn new ones through black holes or quantum fluctuations. It's speculative, sure, but imagine each black hole as a seed, planting the possibility of a new cosmos. Growth is another criterion. Life gets bigger or more complex over time. The universe has been expanding since the Big Bang, spinning simple hydrogen clouds into intricate galaxies. That's not just growth. It's a masterclass in cosmic architecture. Here's where the academic debate kicks in. Scientists love their definitions, but some argue our criteria for life are too narrow, built for carbon-based creatures on a rocky planet. What if life isn't just about DNA and cells? Some researchers propose that any system maintaining order against chaos, like a star forming or a galaxy clustering, could qualify as alive under a broader definition. Others roll their eyes, saying this dilutes the concept of life into meaninglessness, like calling a hurricane alive because it's organized. Where do you stand? Could the universe's ability to create order, stars, planets, you, count as a life process? Or are we stretching the term too far? Picture yourself now, drifting through space, the faint hum of cosmic background radiation tingling in your ears. You see a nebula glowing pink and gold, birthing stars like a cosmic nursery. It's beautiful, but it's more than that. It's a system in motion, transforming raw chaos into something structured. It's hard not to feel a pulse, a sense that the universe is more than a lifeless machine. Maybe it's not alive like a panda or a palm tree, but it's got a vibe, a kind of cosmic groove that suggests it's up to something. Let's bring this into 2025. You're surrounded by systems that blur the line between living and not. AI algorithms that learn, drones that swarm like flocks of birds, even your smart fridge that knows when you're out of milk. If we're building machines that mimic life's behaviors, why not consider a universe that does the same, just on a grander scale? It's like the ultimate open-world video game, with physics as the code and galaxies as the graphics. And here's a quick chuckle for you. If the universe is alive, it's probably annoyed we keep trying to figure it out with math instead of just enjoying the cosmic show. So you're standing at a crossroads. Life, as you know it, is cells, ecosystems, and heartbeats. But the universe challenges you to think bigger. Its energy flows, its structures evolve, and its patterns echo the living world in ways that make your skin tingle with possibility. Could these be the signs of a cosmic organism? Or are we just seeing life where we want to see it? As you prepare to explore the universe's eerie patterns in the next part, take a moment to ponder. What makes something truly alive? The answer might be written in the stars, waiting for you to decode it. You're floating in the void, weightless, surrounded by a tapestry of stars that shimmer like fireflies caught in a cosmic net. The universe hums around you, not with sound, but with a rhythm you can almost feel. A pulse of light from a distant pulsar, the slow swirl of a galaxy, the quiet tug of gravity knitting it all together. You're starting to wonder, what if these aren't just random cosmic events? What if the universe is weaving patterns that look suspiciously like the signatures of life? In this part of our journey, you're diving into the eerie similarities between the universe's structure and the systems of living organisms, searching for clues that it might be more than a lifeless machine. Let's zoom out to see the big picture. The universe isn't a chaotic jumble, it's organized. Galaxies cluster into groups, linked by glowing filaments of gas and dark matter, forming what astronomers call the cosmic web. Picture it like a glowing, three-dimensional spider web stretching across billions of light years, with galaxies as the dewdrops catching the light. Now, think about the systems you see in life, the branching veins in a leaf, the neural networks in your brain, or even the sprawling roots of a tree. These aren't just pretty shapes. They're efficient, adaptive structures that move energy, matter, or information. The cosmic web looks so much like these living systems that it makes you pause. Could this be the skeleton of a living universe? Feel the weight of that idea for a moment. You're standing on Earth, a tiny speck in this vast web, yet you're connected to it all. The same gravity that keeps your feet on the ground pulls galaxies together across unimaginable distances. The same elements in your body, carbon, oxygen, iron, were forged in the hearts of ancient stars. It's as if the universe is a giant recycling system, constantly repurposing its parts to create new structures, new worlds, maybe even new yous. This cycle of creation and destruction feels less like cold physics and more like the heartbeat of something alive. Let's anchor this with a bit of history. In the 1920s, Edwin Hubble, peering through a telescope at Mount Wilson Observatory, discovered that galaxies are racing away from each other, proving the universe is expanding. This wasn't just a random scattering. It was a coordinated motion, like the universe itself is stretching, growing, evolving. Hubble's discovery gave us a glimpse of the universe's dynamic nature, hinting that it might behave more like a living system than a static backdrop. His work showed us that the cosmos has a story, one that's still unfolding, and you're a part of it. Now, here's the quirky detail that'll make you grin. Did you know that the way galaxies cluster in the cosmic web follows a mathematical pattern called a power law distribution? It's the same pattern you see in living systems, like how ants organize their colonies, or how blood vessels branch in your body. This isn't just a coincidence. It's a clue that the universe might be optimizing itself, finding the most efficient way to spread matter and energy across vast distances. It's like the universe took a page from nature's playbook. Or maybe nature learned it from the cosmos first. Either way, it's the kind of thing that makes you wonder if the universe is secretly a math nerd. But let's dig deeper. Living systems don't just have structure, they have behavior. Think about your own body. Your heart pumps blood, your lungs draw in air, your cells hum with activity. Now, look at the universe. Stars pulse with light, cycling through birth and death as they fuse elements and explode in supernovae. Black holes devour matter, spitting out jets of energy that can stretch across galaxies. Even the universe's expansion has a rhythm, accelerating under the mysterious push of dark energy. These aren't random events. They're part of a system that seems to regulate itself, maintaining order against the chaos of entropy. It's almost like the universe has a pulse, a cadence that keeps everything in sync. Here's where the academic debate comes in. Some scientists argue that these patterns suggest the universe could be a self-organizing system, a hallmark of life. They point to how complexity emerges in both biological and cosmic systems. Think of a coral reef building itself over centuries, or a galaxy forming from a cloud of gas. Others counter that these similarities are just analogies, not evidence. After all, a snowflake has intricate patterns, but you wouldn't call it alive. The question is, where's the line? Can a system be considered alive if it shows organization and adaptability on a cosmic scale? Or do we need something more, like intent or consciousness? What do you think? Could the universe's patterns be a sign of life? Or are we just seeing what we want to see? Imagine yourself now, soaring through the cosmic web. You glide past a galaxy, its spiral arms glowing like a whirlpool of light, stars twinkling in a synchronized dance. You feel the tug of a nearby black hole, its gravity warping the space around you like a cosmic whirlpool. The universe isn't static. It's alive with motion, with patterns that seem to whisper, "I'm more than you think." It's hard not to feel a chill, a sense that you're part of something vast yet strangely familiar, like a cell in a body you can't fully comprehend. Let's tie this to the present. In 2025, we're surrounded by systems that mimic life's patterns. Think of neural networks in AI, which organize data in ways that echo the brain or the cosmic web. These technologies show us that complexity and order can emerge without a clear, living spark. If our creations can blur the line between life and mechanism, why not the universe itself? It's like the ultimate open-source project, running for billions of years, constantly tweaking its code to build galaxies, stars, and maybe even us. And here's a little joke to keep things light. If the universe is alive, it's probably got the best Wi-Fi signal ever, connecting every galaxy without a single dropped call. So, where does this leave you? You're staring at a universe that's not just a backdrop, but a system of patterns, filaments, pulses, cycles that mirror the living world. It's as if the cosmos is painting a picture of life on a canvas too big to grasp. As you prepare to explore the Gaia hypothesis in the next part, ask yourself, are these patterns just physics doing its thing? Or could they be the fingerprints of a living universe? The stars are calling, and they might just have a story to tell. You're standing on a grassy hill, the warm sun kissing your skin, a gentle breeze carrying the scent of wildflowers and distant rain. Below you, Earth hums with life, forests breathing oxygen, oceans churning with currents, clouds drifting like thoughts across a living planet. You've seen how the universe weaves patterns that feel alive. But what if our own planet is a clue to something bigger? What if Earth itself is a living system, a precursor to the idea that the entire cosmos could be a single, breathing organism? You're about to dive into the Gaia hypothesis, a mind-bending idea that might just bridge the gap between our world and a living universe. Picture Earth as more than a rock hurtling through space. Imagine it as a single, interconnected system where every part, plants, animals, oceans, even the air you breathe, works together like organs in a body. This is the core of the Gaia hypothesis, proposed by scientist James Lovelock in the 1970s. Lovelock suggested that Earth's biosphere regulates itself to maintain conditions suitable for life, almost like a living creature with a knack for survival. It's not just a poetic metaphor. It's a way of seeing our planet as a self-regulating system, tweaking its temperature, atmosphere, and chemistry to keep life thriving. Now, if Earth can act like a living thing, could the universe be doing the same on a cosmic scale? Feel the ground beneath your feet for a moment. It's not just dirt. It's a network of roots, microbes, and minerals, all interacting to sustain life. The oceans absorb carbon dioxide, the forests pump out oxygen, and even the rocks play a role, locking away chemicals over eons. It's a symphony of balance, like your body maintaining a steady temperature or heartbeat. Lovelock's big idea was that Earth doesn't just host life. It behaves like life itself, responding to changes and adapting to keep the whole system stable. You can almost hear the planet humming, a quiet pulse of activity that's been running for billions of years. Let's ground this with a historical fact. In the 1960s, NASA was gearing up to search for life on Mars, and Lovelock was tasked with designing experiments to detect it. He realized that Earth's atmosphere, rich in oxygen and methane, is wildly out of chemical equilibrium, something only life could sustain. This insight sparked the Gaia hypothesis, showing that Earth's biosphere actively shapes its environment. It was a radical shift, suggesting our planet isn't just a passive stage, but an active player in the game of life. Now imagine scaling that idea up. If Earth can regulate itself like a living system, could the universe, with its cycles of stars and galaxies, be doing something similar? Here's the quirky detail that'll make you smile. Did you know that Earth's oceans and forests talk to each other through chemical signals? Tiny microbes in the sea release compounds that help form clouds, which then rain over forests, feeding plants that release oxygen back into the air. It's like the planet's got its own group chat, coordinating across continents and oceans. Now, think about the universe. Galaxies exchange gas through cosmic winds, stars seed new stars with their remnants, and black holes regulate galaxy growth by blasting out energy. It's not exactly WhatsApp, but the universe seems to have its own way of staying connected, like a giant cosmic ecosystem. But let's dig into the heart of this. The Gaia hypothesis suggests Earth maintains homeostasis, balance, like a living organism. For example, when carbon dioxide levels rise, oceans and plants absorb more, cooling the planet. When ice ages loom, feedback loops nudge temperatures back up. It's not perfect, but it's a system that's kept life going for 3.8 billion years. Now, apply that to the universe. Stars form and die, recycling matter into new systems. Dark energy drives expansion, but gravity pulls galaxies together, creating a kind of cosmic balance. Could this be the universe's version of homeostasis, keeping itself alive in a way we're only starting to understand? This brings us to an academic debate. The Gaia hypothesis has critics who argue it's too anthropomorphic, implying Earth has intent or purpose when it's just physics and chemistry at work. They say life adapts to Earth's conditions, not the other way around. Supporters counter that the planet's self-regulation is so sophisticated it mimics life, even without consciousness. Scale that to the universe, and the debate gets spicier. Can a system be alive if it maintains order and complexity? Or does life require something more, like agency? What's your take? Could Earth's behavior be a hint that the universe itself is a living system? Or are we projecting life onto physics? Picture yourself now, soaring above Earth, the blue curve of the planet glowing against the black of space. You see storms swirling, forests pulsing with green, and deserts stretching like scars. It's a living world, not just because it's full of creatures, but because it acts alive, balancing itself like a tightrope walker. Now zoom out further, past the Milky Way, where galaxies cluster and cosmic forces dance. If Earth can be a living system, why not the universe? It's a thought that makes your heart race, like you're part of something far bigger than yourself. Let's tie this to 2025. Today, we're grappling with climate change, watching Earth systems strain under human impact. Scientists use Gaia-like models to predict how the planet will respond, proof that we see it as a dynamic, interconnected system. If we can think of Earth this way, it's not such a leap to imagine the universe as a cosmic Gaia, regulating itself through gravity, radiation, and expansion. And here's a quick joke to lighten the mood. If Earth is alive, it's probably rolling its eyes at our recycling efforts like, "Nice try, humans, but I've been doing this for billions of years." So, where does this leave you? The Gaia hypothesis shows that Earth behaves like a living system, a small-scale version of what the universe might be doing. It's a clue, a whisper that the cosmos could be more than a collection of stars. It could be a single, interconnected entity. As you gear up to explore the universe's metabolism, in the next part, ask yourself, if Earth can act alive, could the universe be the ultimate living system, with you as a tiny but vital part? The cosmos is waiting to tell you more. You're standing in a vast cosmic forge, surrounded by the roar of newborn stars, their fiery glow casting flickering shadows across nebulae that swirl like paint in water. The universe feels alive with energy, stars blazing, black holes humming, galaxies spinning in a delicate balance of chaos and order. You've seen how Earth might act like a living system. But now you're wondering, could the universe itself have a metabolism? A way of processing energy to fight the relentless pull of chaos? In this part, You're diving into the cosmic dance between entropy and order, exploring how the universe might be metabolizing energy like a living organism. Let's start with a concept you might remember from science class: entropy. It's the universe's tendency to slide toward disorder, like your room getting messier the longer you ignore it. Living things defy this chaos, using energy to build and maintain order. Think of your body turning food into muscle, or a plant weaving sunlight into leaves. If the universe is alive, it should do something similar, right? You're about to see how the cosmos takes raw energy and spins it into structures so complex they make your head spin. From glittering galaxies to the atoms in your fingertips. Picture a star, a massive sphere of plasma glowing fiercely against the cold void. It's not just a ball of fire. It's a cosmic engine, fusing hydrogen into helium, releasing energy that lights up entire systems. That energy doesn't just vanish. It fuels the creation of heavier elements like carbon and iron, the building blocks of planets and, well, you. Now zoom out. Galaxies churn out stars, black holes gobble up matter and spit out radiation, and the universe expands, stretching space itself. It's a cycle of transformation, like a body metabolizing nutrients to grow and sustain itself. Could this be the universe's metabolism? A cosmic process that keeps it alive? Let's anchor this with a historical fact. In the 19th century, Rudolf Clausius, a German physicist, formalized the concept of entropy, describing it as the inevitable drift toward disorder in any closed system. His work laid the foundation for thermodynamics, showing that energy tends to spread out unless something, like life, works to organize it. Clausius didn't know it, but his ideas would later inspire scientists to wonder if the universe itself could be fighting entropy, creating order in ways that mimic life. It's as if the cosmos read Clausius's notes and decided to one-up him. Now, here's the quirky detail that'll make you chuckle. Did you know that black holes, those cosmic vacuum cleaners, might actually help the universe stay organized? They don't just destroy matter. They regulate galaxy formation by blasting out jets of energy that control how fast stars form. It's like a galactic thermostat, keeping things from getting too chaotic. Imagine a black hole as the universe's overzealous janitor, tidying up by shredding stars and tossing out energy to keep the cosmic house in order. It's not exactly Marie Kondo, but it's doing its part. But let's get to the core of this. Life on Earth fights entropy by using energy to build complex structures, cells, tissues, ecosystems. The universe seems to do something similar. Take star formation. Clouds of gas collapse under gravity, heating up to form stars that shine for billions of years. That's not chaos. It's order, sculpted from raw materials. Or consider galaxies, which organize themselves into spirals and clusters, defying the random scatter you'd expect from entropy alone. Even the universe's expansion, driven by dark energy, creates space for new structures to form. It's like the universe is constantly working to keep itself together, metabolizing energy to maintain its cosmic architecture. This brings us to an academic debate. Some scientists argue that the universe's ability to create complexity, stars, galaxies, life, suggests a lifelike process, a kind of cosmic metabolism that counters entropy. They point to how life on Earth emerged from simple chemicals to complex organisms, mirroring how the universe went from a hot soup of particles to intricate galactic networks. Others say this is just physics, not life. Entropy always wins in the end, and the universe's order is just a temporary blip. The question is, does the universe's knack for building complexity make it alive? Or is it just a really fancy machine doomed to wind down? What do you think? Could the universe's fight against chaos be a sign of life? Imagine yourself now drifting through a galaxy's spiral arm, the glow of newborn stars warming your face. You feel the faint pull of a distant black hole, its gravity weaving the galaxy into a cohesive whole. The universe isn't just a collection of random explosions, it's a system, transforming energy into order, cycle after cycle. It's hard not to feel a spark of awe, like you're witnessing a cosmic heartbeat, pumping energy through the veins of the cosmos. Let's bring this to 2025. Today we're building systems that mimic this balance of order and chaos. Think of AI neural networks that learn to organize data, or renewable energy grids that stabilize power flow. These human-made systems echo the universe's ability to channel energy into structure. If we can create machines that fight disorder, why not imagine a universe that does the same, just on a scale that dwarfs our wildest dreams? And here's a quick joke to keep things light. If the universe has a metabolism, it's probably on a cosmic diet, burning stars instead of calories. So, where does this leave you? You're staring at a universe that takes raw chaos and spins it into galaxies, stars, and planets, all while fighting the pull of entropy. It's not just a random explosion. It's a system that feels alive, metabolizing energy to create order. As you prepare to explore the idea of cosmic consciousness in the next part, ask yourself, could the universe's endless cycle of creation be its way of staying alive? The stars are burning bright, and they might just be telling you something. You're drifting through a nebula, surrounded by clouds of gas that glow like a cosmic aurora. There's soft pinks and blues swirling around you like a dream. Stars pulse faintly in the distance, their light flickering as if whispering secrets. You've seen the universe weave patterns and metabolize energy. But now a wilder question tugs at your mind. Could the universe be thinking? Not just alive, but aware, with a consciousness woven into its galaxies and black holes? In this part, you're diving into the speculative realm of cosmic consciousness, exploring whether the stars themselves might hold a mind as vast as the cosmos. Close your eyes for a moment and imagine your own thoughts, fleeting, electric, sparking across the neurons in your brain. Now picture the universe. Its cosmic web of galaxies looks eerily like those neural networks, with filaments of matter connecting clusters like synapses firing across space. Could this be more than a coincidence? You're starting to wonder if the universe is processing information, not just energy, in a way that feels like a mind. It's a dizzying idea, like realizing the night sky might be staring back at you, pondering its own existence. Let's break this down. Consciousness, as you experience it, is your ability to think, feel, and be aware. Scientists still argue about what makes a brain conscious, but one idea is that it comes from complex systems sharing information, like neurons chatting in your head. Now, apply that to the universe. Galaxies exchange gas and energy, stars send light across billions of miles, and even black holes might store information on their event horizons. It's a network of connections, vast and intricate, that makes you wonder if the universe could be aware in a way you can't quite grasp. It's not like it's solving math problems, but maybe it's got its own kind of cosmic thoughts. Here's a historical anchor to ground this wild idea. In the 17th century, philosopher Baruch Spinoza proposed that the universe itself might be a single, unified substance with both physical and mental aspects. He didn't call it consciousness, but his idea that everything, from rocks to stars, might share a kind of universal mind, planted seeds for modern theories like panpsychism. Spinoza's musings suggest that consciousness might not be limited to brains, but could be a property of the cosmos itself. You're standing on the shoulders of his ideas, wondering if the universe is more than matter, It might be thinking matter. Now, for the quirky detail that'll make you smirk. Did you know that some physicists think black holes could act like cosmic hard drives? The holographic principle suggests that all the information inside a black hole is encoded on its surface, like a 2D blueprint of a 3D universe. It's as if black holes are the universe's memory banks, storing data about everything they've swallowed. Imagine the universe as a giant computer, with black holes as its cloud storage, saving every star's story. It's not exactly Google Drive, but it's a wild hint that the cosmos might process information in a lifelike way. Let's dive deeper. The idea of cosmic consciousness often ties to panpsychism, the theory that consciousness is a fundamental property of the universe, like gravity or light. In this view, every particle, every star, might have a tiny spark of awareness, and when they come together in complex systems, like galaxies or your brain, they create something bigger, like a cosmic mind. Picture the universe as a choir, with every star and planet singing a note, blending into a symphony of awareness. It's not like the universe is planning a galactic vacation, but it might have a kind of proto-consciousness, a hum of existence that binds it all together. This leads to a juicy academic debate. Some philosophers and scientists, like those exploring panpsychism, argue that consciousness could emerge from the universe's complexity, just as it does in brains. They point to the cosmic web's neural-like structure, or the way information flows through cosmic systems. Skeptics, though, roll their eyes, saying consciousness requires specific biological processes, not just complexity. A galaxy might look like a brain, but it's not dreaming about interstellar coffee shops. The question is, could consciousness exist without a brain? Or are we projecting human traits onto the cosmos? What's your gut feeling? Could the universe have a mind of its own? Imagine yourself now, floating near a pulsar, its rhythmic flashes washing over you like a lighthouse beam. You feel the faint vibration of gravitational waves rippling through space, carrying whispers of colliding black holes. The universe isn't just a stage, it's a network, buzzing with connections that feel almost alive. It's as if every star, every galaxy, is part of a conversation, sharing information across light years. You can't help but wonder, is this the flicker of a cosmic mind? Or just a beautiful machine running its program? Let's tie this to 2025. Today, we're building AI that mimics consciousness. Think of chatbots that seem to think, or neural networks that learn from data. If we can create systems that blur the line between mechanism and mind, why not imagine a universe that does the same? It's like the ultimate supercomputer, processing information on a scale we can barely fathom. And here's a quick joke to keep it light. If the universe is conscious, it's probably wondering why we keep sending it radio signals like, "Hey, Cosmos, you up?" So, where does this leave you? You're gazing at a universe that might not just be alive, but aware. Its galaxies and stars linked in a network that hums with possibility. It's a thought that sends shivers down your spine, like you're a tiny spark in a cosmic mind. As you gear up to explore the Fermi Paradox in the next part, ask yourself, if the universe is thinking, what's it thinking about? Could you be a part of its dreams? The stars are twinkling, and they might just have something to say. You're standing under a star-filled sky, the cool night air brushing your face, the Milky Way stretching above like a river of light. You can almost feel the universe breathing, its galaxies pulsing with the rhythm of creation. You've wondered if it could be alive, even conscious. But now a new question grips you. If the universe is a giant living organism, are you just a tiny cell in its cosmic body? And if so, why haven't you heard from other cells, alien civilizations out there? You're diving into the Fermi Paradox, the eerie silence of the cosmos, and how it might connect to the great living hypothesis. Picture yourself as a microscopic part of something vast, like a single cell in a whale, unaware of the larger creature you're part of. If the universe is alive, maybe you, Earth, and all its life are tiny components of its grand system, each playing a role in its cosmic metabolism or consciousness. But here's the puzzle. If the universe is teeming with potential for life, why haven't you picked up a single cosmic phone call? This is the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" With billions of stars and planets out there, you'd expect alien signals, spaceships, or at least a cosmic tweet or two. Yet, the universe is silent. Could this silence be a clue to its living nature? Feel the weight of that silence for a moment. You're gazing at the stars, their light traveling millions of years to reach you. Yet none carry a message from another world. The universe feels vast, almost lonely, but also strangely purposeful, like a body quietly doing its work. The Fermi Paradox challenges you to wonder, maybe the universe doesn't need alien civilizations chattering across space. Maybe life, like you, is scattered across its body, not to talk, but to function. Each planet a cell contributing to the whole. It's a thought that makes your place in the cosmos feel both tiny and profound. Let's anchor this with a historical fact. In 1950, Enrico Fermi was having lunch with colleagues at Los Alamos when he posed his famous question about the absence of alien life. His back-of-the-napkin math suggested that, given the age and size of the galaxy, advanced civilizations should have colonized it by now. Yet we see no signs of them. No megastructures, no radio signals, nothing. Fermi's question sparked decades of debate, pushing scientists to wonder if life is rare, if intelligence is fleeting, or if there's something bigger at play, like a universe that doesn't need interstellar small talk. Now, here's the quirky detail that'll make you grin. Did you know that some scientists think the Fermi Paradox could be explained by cosmic sociology? The idea is that alien civilizations might be out there but deliberately hiding, like galactic introverts who've turned off their read receipts. This zoo hypothesis suggests they're watching us, waiting for us to mature before making contact. Now tie that to the great living hypothesis. If the universe is a living organism, maybe its cells, like us, aren't supposed to chat yet. Maybe we're all quietly doing our part, like neurons in a brain that don't directly talk to each other, but still make the whole system work. Let's dig deeper. If the universe is alive, life like yours might be its building blocks, scattered across planets to serve some cosmic purpose. The Fermi Paradox could hint that life isn't meant to connect across stars, but to contribute to the universe's larger metabolism or mind. Think of Earth as a tiny organ, processing energy, evolving complexity, maybe even adding to a cosmic consciousness. The lack of alien contact might mean the universe doesn't need its parts to meet. It needs them to function locally, like cells in a body working together without ever meeting. It's a wild idea. You're not alone because you're isolated. You're alone because you're part of something bigger. This brings us to an academic debate. Some scientists argue the Fermi Paradox suggests life is rare or short-lived, with civilizations wiping themselves out or staying quiet to avoid threats. Others, leaning into ideas like panpsychism or the great living hypothesis, propose that life's role isn't to colonize or communicate, but to contribute to a larger system. If the universe is alive, maybe its cells don't need to talk, just as your heart cells don't send emails to your brain. The question is, Does the silence of the cosmos point to a universe that's indifferent, or one that's alive with a purpose we can't yet see? What's your take? Are we alone because we're rare, or because we're part of a cosmic whole? Imagine yourself now, floating above Earth, the planet glowing blue against the starry void. You feel the faint hum of the universe, its galaxies spinning, its stars burning, all connected in a vast network. The silence of the Fermi Paradox isn't empty. It's heavy with possibility, like the quiet of a forest before dawn. Maybe you're a cell in a cosmic organism, your existence a small but vital part of its grand design. It's a thought that makes your heart race, like you're on the verge of a cosmic secret. Let's tie this to 2025. Today we're scanning the skies with telescopes like the James Webb, listening for signals with SETI, and even sending our own messages into space. Yet, the universe stays quiet, like it's holding its breath. If it's alive, maybe it's not ready to reveal its full story. Or maybe we're not ready to hear it. It's like waiting for a text from a friend who's just too busy running the cosmos. And here's a quick joke. If the universe is alive, it's probably ghosting us because we keep asking, "Are you out there?" without sending snacks first. So, where does this leave you? The Fermi Paradox paints a universe that's silent, yet brimming with potential, where you might be a tiny part of a living cosmos. As you prepare to reflect on your place in this grand system in the next part, ask yourself, are we alone because we're insignificant, or because we're essential to a universe that's alive? The stars are quiet, but they might just be waiting for you to listen. You're standing on a quiet beach at twilight, waves lapping at the shore, their rhythm echoing the faint pulse of stars overhead. The salty breeze carries a whisper of the infinite, and as you gaze at the cosmos, you feel it, a connection to something vast, something that might be alive. You've journeyed through the great living hypothesis, exploring patterns, metabolism, consciousness, and the eerie silence of the Fermi Paradox. Now, it's time to reflect. If the universe is a living thing, what does that mean for you? What's your place in a cosmos that might be breathing, thinking, evolving? Take a deep breath and let the idea sink in. The universe isn't just a backdrop of stars and galaxies. It could be a single, colossal organism, with you as a tiny but vital part. Picture yourself as a cell in this cosmic body, your thoughts and actions rippling through its vast system. Every choice you make, every breath you take, is woven into the fabric of a universe that might be aware, pulsing with purpose. It's a thought that hums in your chest, like the afterglow of a song you can't quite name, making you feel both small and profoundly significant. Let's rewind to the journey you've taken. You've seen the universe's web of galaxies, eerily similar to neural networks, suggesting a structure that's more than random. You've watched it metabolize energy, turning chaos into stars and planets. You've pondered if it could be conscious, a mind woven through the stars. And you've wrestled with the Fermi Paradox, wondering if the silence of the cosmos means you're a lone cell or part of a greater whole. Now, standing at the edge of this idea, you're left with a question. If the universe is alive, how does that change the way you see yourself? Let's anchor this with a historical fact. In the 4th century BCE, the philosopher Plato described the universe as a living being endowed with soul and intelligence, a cosmos animated by a divine order. His words, written long before telescopes or equations, capture a timeless human instinct to see the universe as more than matter, as something alive and purposeful. Plato didn't have data, but he felt the same awe you do now, gazing at the stars and wondering if they're part of something greater. His intuition echoes in the great living hypothesis, urging you to see the cosmos as a partner, not just a place. Now here's the quirky detail that'll spark a smile. Did you know that the cosmic microwave background, the faint glow left over from the Big Bang, has tiny fluctuations that look a bit like a cosmic heartbeat? These ripples, mapped by satellites, show patterns in the early universe that seeded galaxies, like the first thump of a pulse setting the rhythm for everything that followed. It's as if the universe started with a beat, and you're still dancing to it billions of years later. Not exactly a chart-topping single, but it's the oldest rhythm in existence. Let's dive deeper. If the universe is a living organism, you might be one of its countless cells, each contributing to its grand existence. Think about your own body. Your cells don't know the bigger picture, but they work together to keep you alive. Maybe you're doing the same for the universe, your life, your curiosity, your creations, adding to its complexity or consciousness. It's a humbling idea, but it's also empowering. Every time you learn, love, or dream, you're part of a cosmic story, a tiny spark in a system that spans light years. This brings us to an academic debate. Some thinkers argue that seeing the universe as alive gives meaning to human existence, connecting us to a larger purpose. They say the great living hypothesis reframes our role, making us active participants in a cosmic organism. Others caution that this is poetic but unscientific, a projection of human desires onto a universe that's ultimately indifferent. Life, they argue, is a local phenomenon, not a cosmic one, and meaning comes from us, not the stars. What's your stance? Does the idea of a living universe make you feel connected? Or is it just a beautiful story we tell ourselves? Picture yourself now, lying on the sand, the cool grains pressing against your back as you stare at the Milky Way. You feel the universe's vastness, its stars twinkling like neurons firing in a cosmic brain. It's not just out there. It's in you, in the carbon of your bones, forged in ancient stars. If the universe is alive, you're not separate from it. You're a thread in its tapestry, a note in its song. It's a thought that makes your heart skip, like you've just glimpsed a truth too big to hold. Let's tie this to 2025. Today, we're pushing boundaries, building AI that thinks, exploring Mars, mapping the cosmos with ever sharper telescopes. Yet the more we learn, the more we realize how little we know. The great living hypothesis reminds you that science isn't just about answers. It's about wonder, about asking questions that stretch your imagination. It's like scrolling through an endless feed of cosmic mysteries, each one begging you to swipe up and explore. And here's a quick joke. If the universe is alive, it's probably tired of us asking for its Wi-Fi password to decode its secrets. So, where does this leave you? You're part of a universe that might be more than a machine, a living, evolving entity with you as a vital piece. It's a call to keep exploring, to keep questioning, to keep adding your spark to the cosmic whole. What does it mean to be a cell in a living cosmos? How will you contribute to its story? Drop your thoughts in the comments below. Let's keep this cosmic conversation going. Hit that like button if you're as awestruck as I am, and subscribe to stay part of this journey. The universe might be alive, and it's waiting for you to write the next chapter.